algebraic expressions and equations. Good day, students. Welcome back to my classroom. For today's lesson, you are going to learn how to differentiate expression from equation, translate verbal expressions and equations into algebraic expressions and equations and vice versa, and lastly, identify a variable in an algebraic expression and equation. Let us begin. Let's have our brain exercise. Let's take a look at this one. We have the sum of 8 and 9. Can you translate this into a numerical expression? Great job! We have here the keyword sum, which represents addition. This means that we need to add 8 and 9. So that is 8 plus 9. And this is an example of a numerical expression. Next one, we have the sum of 4 and a number. Again, our keyword here is sum, which means addition. This means that we need to add 4 and a number. Here, we do not know the value of a number. Therefore, we are going to represent it by a letter. Let's say letter N. So that is 4 plus N. This is an example of algebraic expression. Next one, we have the sum of 4 and the number is 7. Again, our keyword here is the word sum, which means addition. And we need to add 4 and a number, which is 4 plus n. And the word is represents equal sign. Therefore, 4 plus n is equal 7. This is an example of algebraic equation. Now, do you know what is the difference between algebraic expression and equation? Let's go and take a look. Let us discuss the differences between expression and equation. In algebraic expression, it is a mathematical phrase. For example, we have the sum of 4 and a number. And as we can see, this is not a complete sentence. While the algebraic equation is a mathematical sentence. For example, we have the sum of 4 and the number is 7. Another one is algebraic expression has no equal sign, while in algebraic equation, it has equal sign, which represented by the word is. Lastly, in an expression, a value of the letter or the symbol can change. For example, here we have 4 plus n. We can say that the value of n is 5. So that would be 4 plus 5. Or we can say that the value of n here is 9. So that would be 4 plus 9. Or let us say it is equal 2. So that would be 4 plus 2. On the other hand, in algebraic equation, the value of the letter or the symbol cannot be changed. It has a fixed value or fixed answer. Here, in 4 plus n equals 7, we cannot say that the value of n is 9, as it will not say that the equation is correct. If we say that the value of n here is 2, the equation would be wrong. What if we say that the value of n here is 3? 4 plus 3 equals 7, and that is the correct value of n. Wonderful! Now that you know the differences, let's move on to the parts of algebraic expression. The first one is the variable. The variable is any letter or symbol that represents a number. Here, the variable is letter x. The next one is the coefficient. The coefficient is a constant value used with the variable. It is the factor or the number being multiplied to a variable. Here, the coefficient is 2. We can always find the coefficient before the variable. The next one is the constant. The constant is a fixed value that does not change. Here, the constant is number 5. And lastly, we have the term. The term is a number or variable, a product or quotient of a number and variables separated by plus or minus sign. Here, in a given example, we have the plus sign, and it separates two terms, which are 2x and 5. Remember that addition and subtraction only separate terms, while division and multiplication do not separate terms. Now that you already know the parts and the differences between equation and expression, let us go and translate some verbal expressions. Here we have a number plus 3. First one that you need to know is what is the missing here. The missing here is a number. This means that we are going to represent it by a variable. Any letter that you would like to. Let's say I want letter M. The next keyword here would be the word plus, which means addition. So that is M plus 3. So our algebraic expression here is M plus 3. Now let's have another example. We have the sum of a number and 3. Again, let's take a look for some keywords. Here, the keywords that we have is the word sum, which means addition. Therefore, we need to add a number which can be represented by a variable, let's say letter M, and the number 3. So that is M plus 3. Very good. Let's have another one. We have M increased by 3. Here we already have a variable which is M. So let us write M. Next we have the keyword increase by. Increase by represents addition. So that would be a plus sign. And lastly, the number 3. Next one, we have 3 added to M. So again, we already have a variable which is M. And we need to add 3 to it. So that is M plus 3. Next one, we have 3 more than M. Again, our variable here is M. And the word more than represents addition. And we have 3. So that is M plus 3. Now let us identify which are the variable, coefficient, constant, and the number of terms here in our given algebraic expression. The variable here is the letter, which is M. Very good. Next one, let us take a look for the coefficient. Again, the coefficient is the number that we see before the variable. As we can see, there is no number before a variable here. But it doesn't mean that we do not have a coefficient. Remember that a coefficient is a factor or a number multiplied to a variable. All variables that do not have a number beforehand has a coefficient of 1 because it means 1 times m, which is equals m. So the coefficient here is 1. Next one, the constant here is very good. It is 3. And let us count the number of terms. Since this algebraic expression is separated by a plus sign or addition, our terms here are m and 3. So we have 2 terms. Great job! Let's have another example. Next one, we have a number minus 7. Again, we have here a number which can be represented by a variable. So let us say letter F. Our next keyword here is the word minus, which represents subtraction. And there is 7. So that is F minus 7. Next one, we have the difference of F and 7. So again, let's take a look for some keywords. We have difference, and the difference represents subtraction. So we need to subtract F and 7. Alright, let's have another example. We have F decreased by 7. So our variable here is F, and we need to decrease this one, which represents subtraction by 7. Next example, we have 7 subtracted from F. So our variable here is the letter F, and we need to subtract 7 from it. So that will be F minus 7. And lastly, we have 7 less than F. And our variable again here is letter F, and our keyword is less than, which means subtraction 7. So that is F minus 7. Now, let us identify the variable here. Again, our variable is the letter, which is very good, is letter F. And now, let's take a look for the coefficient. Since there's no number before our variable here, therefore the coefficient here is 1. Next one is the constant. The constant here is -7. Now, let us count the number of terms. So we have here minus that separates the terms. So we have F and 7. So that is 2 terms. Alright, let's go to our next example. This time we have a number times 2. Again, we have here the missing value, which is a number. So now let's represent it by a letter. Let us say letter N. Times, which means multiplication, 2. In an algebraic expression, we do not use the multiplication sign as it confuses us into a variable x. Instead of using the multiplication sign, the number, we just simply combine the number and the variable. So that would be 2n. Next example, we have twice of n. Here, our variable is n, and our keyword is the word twice, which means 2 times. So that is 2 times n. Therefore, that is 2n. On to our next example, we have n multiplied by 2. Here, our variable is letter n, and our keyword is multiplied by 2. So we need to multiply n by 2, so that will be 2n. Next one, we have the double of n. Here, our keyword again is double, which means times 2. So we need to times 2 the letter n. So that is 2n. Alright. Next one, we have the product of n and 2. So our variable here is n, and our keyword is product, which is the answer for multiplication. This means that we need to multiply n and 2. So that is 2n. Now let us identify the variable here. The variable here obviously is the letter n, while the coefficient is 2, as it is the number before the variable. Next one is the constant. As we can see, we do not have a constant here. While the number of terms, since there's no addition or subtraction that separates the term, we only have 1 term. Now let's move on to our next example. Next one, we have a number divided by 5. Again, we have the missing value, which is a number. So let us represent this by a variable n. And we need to divide this by 5. So we can write this as n divided by 5. Next one, we have the quotient of n and 5. So again, our keyword here is the quotient, which means division. So it means that we need to divide n and 5. So that is n divided by 5. Next one, we have 1/5 of n. So it means that we need to multiply 1/5 and n. So that is 1/5 n. But it can also be written as n over 5. Okay, next one, we have the ratio of n to 5. Our variable here is n. And our clue word here is the ratio of. We all know that we can represent ratio by a fraction. So that would be n is to 5 or n over 5, which also means n divided by 5. Now our variable here is the letter n, while the coefficient here is 1/5, as this is the factor or the number being multiplied to the variable n. Next one is the constant. Here we cannot see a constant, so that will be 0 or none. While the number of terms, since there's no addition or subtraction that separate the terms, this means that we only have one term. Great job! Now that you already know some basics, this time let's try to translate a verbal expression with more than one operation into algebraic expression. Let's have our first example. 6 more than twice a number. So again, we need to take a look for some clue words in order for us to translate this one. So our clue word here, as we can see, we have twice a number. And we all know that that means 2 times a number or a variable. So we can say that is 2a. And next one, we have 6 more than. And that is plus 6. So therefore, our expression here is 2a plus 6. Wonderful. Now let's identify the variable here is a. Good job. While the coefficient here is 2. Next one, the constant is 6. And we have here 2 terms, which are 2a and 6. Let's have another example. This time we have 18 less than half a number. Now let's take a look for some keyword. We have here 18 less than. And we all know that less than means subtract. So that is minus 8. Next one, we have half a number, and that means 1/2 times a number or a variable. So that would be 1/2 y. Now if we combine them together, we have 1/2 y minus 8. So that is 18 less than half a number. So here our variable is y, while the coefficient here is 1/2, while the constant is negative 18 or minus 18. And the number of terms here are 2. That is 1/2 y and 18. Now let's have another example. We have 1 plus twice a number is 10. So our first clue word here is to rise a number. And that means 3 times a variable. So we can say it is 3b. Next one, we have 1 plus, and that means plus 1. If we combine that together, we have 3b plus 1. And we still have more to translate. Here we have the word is 10, which means that equals 10. So that is 3b plus 1 equals 10. So here we have the variable b, while the coefficient here is 3. The constants are 1 and 10. And the number of terms here are 3, which are 3b, 1, and 10. This time, let us translate an expression into a verbal or word sentences or phrases. Here we have b plus 8 divided by 2. So first we have b plus 8. We can write this one as the sum of b and 8. And next we have divided by 2. So that would be divided by 2. Now we have the sum of b and 8 divided by 2. Wonderful! Let's have another example. Here we have 3n plus 25 equals 31. First, let's try to translate plus 25. We can translate this one as 25 added 2. But I will use 25 added 2. Next, we have 3n. This means that 3 times n. But we can also say thrice of n. And lastly, we have equals 31, which means is 31. So now we have 25 added to the raise of n is 31. Good job, students! You made it this far. Now here are the things that you learned today.